Hey everyone, my name is Sagar Kesarpu, and I'm a senior principal engineer at Discover. Yeah, and here are my colleagues. So let's get started. So I'm sure. So this would be the agenda. Like, what would be the problem with traditional onboarding, chaos-driven onboarding? Like, we'll explain in detail on how we can do that. Then the implementation guide will show you a small demo, and to see how we can run these chaos experiments. And then we can see some tools that can be used for chaos-driven onboarding. And after that, at the end of the session, you will get to know on how you can get started today itself with the information that you have taken out from here. Okay, so let's get started. So, everyone would have been onboarded at some point in your life into a new team, right? So what do you get? As soon as you get into the team, they throw you tons of notes or PDF or Word documents, right? They say, go read through it, try to understand the architecture, try to implement, and then so on. Like, they give you a week or 2 weeks of time. But does that really help new hires? I don't think so, right? So the best way to do is to help them actually practice those things, right? So that is what I'm saying here, that the documentation is too much of an overload, and there would be very less gap between the theory versus the reality gap, right? So there would be, when you're given documentation, there would be no way to practice real critical incident responses, right, during a real emergency. So that would be a big roadblocker for any new hire who's joining the team, right? So then you will also be missing the real team dynamics. When I say team dynamics, basically, how does the team respond when a new incident has come up, right? A new hire might not be going through that process. So through this onboarding, you can add those steps as well, so that they can understand the team dynamics. So those missing team dynamics, you can always add through in your onboarding document as well. So basically, we want engineers to be incident ready, not just document trained or something like that, right? So these are the traditional onboarding problems that we can face nowadays. Then what are the core principles of chaos-driven onboarding, right? So the first one would be experiential learning, like experiential learning. So what I mean by that is, like, you learn by doing things, not just reading documents, right? So you will be specifically solving those real problems with actual systems. So that is how you will learn. So then the next one would be system thinking, right? So what is system thinking? Like, you have to understand the dependencies, you have to understand the architecture, you have to understand all the observability tools that are out there. And when an incident comes, what are the recovery paths for that particular experience? So all this, if you face firsthand during your onboarding itself, that would be of great help for the new hires, right? So basically, for example, you can say that, for example, if you have a payment gateway, right? So when you're onboarding new engineers, you simulate those payment gateway failures. Instead of reading about those retry scenarios that you do during failures, teach them, like, they can learn firsthand on how a missing transaction flows through logs or dashboards and alerts. So that is what system thinking is. Then the next one is psychological safety. So what do you mean by psychological safety is that you create a controlled environment, like you create you spin up an environment where they can practice these onboarding steps, right? So create this controlled environments, and even if they fail, try to accept that failures, because only if you fail, you learn something. So that is what psychological safety means, okay? Then collaborative problem solving. So basically, when an incident comes, I have seen even in the PARs that I have attended, some of the main reasons why the PARs are so slowed down is because of not having proper communication when an incident comes, and the coordination that needs with different teams, right? So collaboration is key here. So these exercises that you do during chaos experiments, it will help strengthen team communication and coordination, which are critical during the real incident response. Okay. So what I would like you guys to take message from this is, we don't just teach tools, we teach resilience and teamwork. Okay. So how do you design your first chaos experiment? So what I would say is, like, the first step, choose a realistic scenario. Like, pick up a scenario which has happened in your last 6 months. Everyone would have faced an API timeout or a DNS failure or things like that. So that would be the first step. Then you should have clear learning objectives. So when I say clear learning objectives, so what do the new engineers should take away is like how do you do analysis using the logs? What are the rollback procedures? What are the debugging practices that you have? What are the tools? What is architecture? So those are the clear learning objectives that you have to define. Okay. Then like I told in the previous slide, set up a safe environment. Safe environment is like you can create isolated development environments with fake data. Like for example, if you have any bank related data, right, you will be having sensitive information. So try to replicate production level data, and even if they fail with that data in this environment, it should be fine. So they will learn from the mistakes there again. Okay. Then you have to create the chaos experiment recipe. So basically, you need to have what is the failure injection that you're doing, then what is the success criteria for it, and what is the rollback procedure. So for every incident that you, every chaos experiment that you do, try to have these steps documented. Okay. Then at the end, like you can prepare a facilitator guides, like what should the new hire do, like in terms of hints, expected observations during incident response, or the questions that you have discussed during your debrief, right? Yeah. Okay, so let's move on to the next one. Okay, so here I would like to share a couple of, three of the sample chaos scenarios. So if you see, the first one is broken deploy. So what you do during a broken deploy chaos experiment is introduce a subtle bug that causes the application to crash, right? And under specific conditions. So you should be knowing the specific conditions as well. So basically, let the new hires identify the issue, try to understand what can be the rollback procedures, and then implement a fix, right? So the skills that would generally be required here is like log analysis, deployment pipelines, and debugging, right? So basically, what I would say is, you can say, for example, if you're in a fintech company, introduce a bug in a sandbox that causes like a login service or something to fail. Then new hires have to identify the rollback commands in the Jenkins pipelines, right? So it will mirror an incident that you had already had earlier. Okay, so that is what broken deploy is. Then you have DNS black hole. So basically, you have to simulate the DNS resolution failures to a critical dependency here. So I'm sure everyone would have had these issues in their working career. If you want a real life instance, in 2016, there was a major provider, DYN DNS, like it went down due to a DDoS attack. So many big names like Twitter, Spotify, Reddit went offline because of this. But if you would have practiced this chaos experiment, maybe you would have saved these like big companies from going offline, right? So that is what a DNS black hole is, experiment that you can conduct. And again, the skills that you need here is network diagnostics, resilience patterns, and configuration management. Then I'm sure everyone would understand what a slow API is. So basically, you introduce manually a latency to a critical API. Then engineers must detect performance degradation, identify bottlenecks, and implement this timeout or retry strategies, right? So basically, for example, if you take it from an e-commerce perspective, so you can inject a latency into the product API. Then new hires learn to spot degraded performances in Grafana. So you can use tools like dashboarding tools like Grafana, and Grafana is here already, and apply the retry logic, right? The excess reflected actual peak season slowdowns. So that is what this experiment helps you with. So basically, by grounding scenarios in real history, we make onboarding not just educational, but more immediately relevant. Okay, so now I'll hand it over to my colleague Pat here, and he will show you a small demo with a couple of experiments.
Thank you, Sarkar, for taking us through the intro and giving a background about the chaos engineering. So I'm going to talk about showing the demo. For that, I'm just giving a technical background, what we have set up, right? So I have the set up the local kind cluster, and then install the great application pod info. I think most of you are familiar with that. And with the front end, back end, with 2 replicas, and Redis to serve the data, and Prometheus to collect the metrics, and Grafana to visualize them. And then for the chaos experiment, I have used the chaos mesh. Okay, so let's go. Okay. So let's talk about, let me give you a little background about one of our new engineers, John, who joined us in my team a few weeks back. And then as a part of our knowledge transitions, we provide the documentation to read about what the tools are we are using. So he's smart and knowledgeable, and he picked up quickly to understand the part info applications, how that works. And then and then understands the other tools like Grafana. So Grafana and other tools. So he go into the system and looks like to understand how the steady state looks like, right? So he looked at the graph, use CPU usage, memory, everything stable, and request throughput. It's going like around 300 requests, and then the latencies are stable, right? So this normal or the steady state look like. So what happens when so after a few weeks, right? So all of a sudden the customers are experiencing slowness in the application, and slowness into the application. So John is though read about the what needs to done after that, right? So like based on our run book, so he has to go through the Grafana and look at it, what the next step. But though he read about the documentation, but he's not confident, slightly panicked too because of the first incident, right? He panicked, and then he might need some help from somebody. So that situation, right? So let's create the similar situations. Let's create and see how that can be done if we experiment with introduce him with the training with a chaos experiment. Okay. So I have the CPU stress chaos, which has the backend stress. So I'm going to apply and then see how that behaves, which the similar slowness it's happening at the real environment. I am not sure. Let's see. Anybody knows? Okay. Thank you. Okay. So I started the stress chaos. This is using the chaos mesh, and it's applying on the one of the pod, which is running on the test namespace with backend pod info, which applying the CPU to core and then node 100 for the next 3 minutes. So let's see how that behaves in the environment, and then how we can learn from that. So it's already you are looking at this, right? There is a little bit of spike into the CPU. So because of the load which we created, and also the request throughputs, it's coming down, and look at the latency also, it's spiking up, right? So this is a real incident. It's happening at the same John faced the slowness in the customers talk about the slowness, and then so when you look at it. So based on the run book, what we have mentioned is either kill the pod, which is too much of stressed out, right? So maybe because of the bad connections with the application, so it might be we need to kill the pod, right? So instead, what John decided to do, apply the HPA to like increase the load or spread out the load so that it can just evenly spread out to the other part, which it will still serve the like customers can get the smooth experience, right? So for that, the HPA I just applied, I think many familiar with that. So just resources and a minimum min and max replica 2 and 5, and then if it reaches above 70% of the utilizations, it will spin up the additional parts. Okay, so let's go here and then wait for a few minutes. I think it will take time, and then so it's. Yeah, so you can see that the backend part, it's already come up into the 4, right? Because it's because of it's evenly, the Kubernetes, it's automatically applies the horizontal part scale, and then it comes up, and then automatically it's started seeing that it's spreading the request properly. Okay, so what basically the learning is within the 5 minutes we are able to reproduce or create the similar incidents whatever it happened in the past, right? So the John learned it to diagnose based on the Grafana signals and fixed it by applying the HPA. The takeaway is basically with a safe and controlled environment. It's John gained a hands-on confidence. And then not just reading the document or wiki, but he lived through the real incident, what it can happen in the production environment. So it also you can also try with similar incidents whenever the new hires or new engineers join into a team, and then experiment with whatever the past incidents. So that will help them to not just read the document; they can really experience it. So it will help them to reduce your MTTA and MTTR, and then for the real incident cases. Okay. So what we have basically what we have done is we defined the scope and baseline to establish the. Define the scope and baseline for the pod info, and then we looked at it how the CPU memory and then other latencies looks like before we start the experiment. And then inject the chaos mesh experiments with stress chaos. So we can try different chaos experiments with network latency and other stuff. And finally, observe what is happening at the when the chaos experiment is happening, right? Observe using a Grafana or any other tool, observability tool like Datadog or Instana, so you can use it. And finally, analyze the impact and what actions you have made, and then learn from it. So apply some different. So I have shown the HPA, so maybe you can apply for different cases, maybe timeout, retry, and circuit breakers, and all other different patterns you can apply to improve your performance or come out of that situation. Okay, so now I hand over to Gunjan.
Yeah, that's all right. Thanks, Pat. Hi, I'm Gunjan Taleja again from Discover. I'm just going to go through some of the other Chaos onboarding tools that we have in the current market. I think I'm sure from few of are familiar with some of those, like the Chaos Toolkit, which is another open source tool. It's another open source tool known as CTK. And basically you can add it or use it in different ways from your API testing and your network stuff. You can easily integrate those with your CI/CD as well. So the idea is whatever we just went through Chaos Mesh, you can basically have the similar experiment using Chaos Toolkit. One of the easiest one to go is like the Chaos Monkey that comes part of the Spring Framework, which is inlining but kind of has some limitations to it. So the idea here is to basically test it, create those hypotheses, and have a proactive analysis. And definitely the key thing here is to onboard the new joinee to the team, right? So it's an easy onboarding from a new hire perspective, right? Chaos Mesh, we just had a demo. I think that's about Chaos Mesh. The next thing is the proxy. which we use primarily for our network chaos engineering steps, mostly from think about it as a stress test of your network stuff, not just your application. How do you basically add latencies or some kind of delays or some kind of DNS block hole, which Sagar gave an example, right? That kind of falls under the toxic proxy protocol, which kind of helps you not only with your normal application stuff, but you can actually build those around your DR planning. Like if you have a ADR, like as a disaster recovery program, right? So you can include those as part of your chaos engineering, as well as align it with your CI/CD in terms of deployment handling, in terms of networking, other stuff. And there are other supporting infrastructure. I think some of the examples which Sagar and Pat already mentioned, like you have a sandbox environment, the way Pat set it up for K or K8s and all, you can have your own isolated sandbox environment just for your chaos. So that way, anytime you onboard a new experiment, it's easy to plug and play into an existing infrastructure, visually like a production-like, but still a sandbox for easy plug and play for anybody. CI/CD, again, like you have CI/CD stages for anything that you have, like from a testing perspective, from your different quality gates. You can have one for your chaos experiment, which is basically you have a chaos engine added to your CI/CD pipeline to easily basically run those experiments as part of your even production and pre-production loads. Observability stack, I think we showed the Grafana. I think we definitely use a couple more like Datadog and Instana in the past for the similar stuffs. And that's kind of easily linked to your chaos experiment. You don't have to do anything out of the box to just have this chaos experiment into your system. And other tools like collaboration tools, you can have this CI/CD linked to with your change management protocols, like not the CI/CD, your chaos experiment results linked to your incident management, change management, so how they can be easily tracked and kind of send out using their observability tools at the same time. Okay, the other thing, one important thing that we have done in the past is some kind of a drill, which we called as a game day within our company. So we do run those game days based on what kind of application we have. We have different flavors of application running in our system, like we have a lot of digital stuff, a lot of cloud deployments, and we definitely have some legacy application which is sitting on-prem, which is one of the pain points to have chaos engineering done, because when those were set up, right, this chaos engineering practice and being onboarding with new members was not very vigilant. So going forward, adding this as part of your onboarding process is going to ease out things as the system progresses, as the system builds. So the same thing happens within drill, like you set up a baseline. This is what we're going to test. You define a healthy pipeline that this is how your system should behave. Then the next step to it is to create a hypothesis, formulate a hypothesis saying this is what we're going to do and this is how it should behave. And then followed up with a blast radius where we don't want to test everything. We don't want to go out of the box like to everything that we want to do in a case study. We should define a blast radius to make sure that the tests are happening within the same boundary. And definitely at the end, you have to investigate and analyze the results once the drills are done. And again, these all could be tied together with your normal life cycle of the project, nothing different than this. So anybody who is joining the team newly, it's not that difficult to get into once you have this as part of your onboarding exercise. There are a few real-world examples. These are just information like on a different area, like some of the SaaS product companies, how they are doing it, implementing a game day. And then there is a SRE team who's doing the similar stuff in a fintech world, and what they would do, they would like introduce chaos drills where new SREs where tasks were identified and mitigated database connection issues, partial service degradation. So basically this helped them reduce the average time to resolve, basically trying to achieve an MTTR which is compliant not only from an organization perspective, but from a competition perspective, you have to have it reduced MTTR over a period of time. So these drills and these chaos engineering helps you get there. And then there's an example of the fault injections, Fridays. Like some teams there's a company that does that. They do have a dedicated Fridays to doing some of these experiments. So, okay, how do we start now? Like we went through a sample demo, we went through the psychological aspect of things, we went through how the onboarding things work, right? So it's pretty simple. It starts small with one simple failure scenario, then document your chaos experiment recipe. I think Sagar gave us some highlight and Pat set up some of those scenarios over here. Set up the sandbox environment with the guardrail. We don't want to expand this horizon or expand the experiment so it gets confusing. And make sure that pilot with the new members, making the senior members as the leader to run these experiments, so it's easy to transition some knowledge or do some hand-holding together to know that they understand what they're actually doing. So just to wrap up, so the goal isn't to stress out the new hire, it's to build confidence through controlled experiment and scenarios. So start building resilient engineers from day one. And there's something I would like to add was like trying to build a culture of resiliency to start with. Like we have been thinking of shifting left a lot of stuff, but chaos engineering is something which has been kind of on the side. So one thing I would kind of incline towards is build a culture of resiliency, which is kind of adding things to your onboarding process. Yeah. Thank you. That's all from our side. Thanks.